Graphics hardware is becoming more programmable, and high-level shading languages have been developed to allow users to create interesting effects. However, programmable hardware has resource constraints. For example, a modern Fragment processor has a limited number of interpolants, registers, texture units, and instructions. Shaders that violate resource constraints cannot be mapped to a single rendering pass. The problem we address in this paper is splitting shaders into passes that meet the resource constraints and render efficiently. Our solution is an algorithm called RDS. We integrated RDS into the Stanford Real-Time Shading System. Let's examine how our system compiles a shader. The shader is converted from shading language source code to an intermediate representation. The compiler then performs instruction selection to build a DAG of hardware-specific fragment operations. If the DAG is too large to be mapped to a single pass, the compiler calls RDS to partition the DAG into multiple passes. RDS uses a hardware-specific cost model to find a partition with near minimum cost. Sometimes duplicating nodes reduces this cost. After the shader has been partitioned, the compiler generates assembly code for each of the passes. These passes are then ordered and sent to the GPU for rendering. We now demonstrate this system rendering a shader using multiple passes on a 1.4 GHz Pentium 4 system with an ATI Radeon 8500 graphics card. This shader is a version of the RenderMan bowling pin with 1 point light source and 4 animated textured lights. The shader renders in 7 passes at 30 frames per second at a resolution of 512 by 512. The interactive rate allows the user to manipulate the object and move the lights.